Hello, everyone. Hi, everyone. My name is Adrian, and I've been at Google for about a year. I'm principal architect for the Web3 specialist team, and I've been in crypto since 2015. In quite a while. I've been working about 4 years for Consensus, working on Infura and also MetaMask as head of engineering. Right. So today, I want to talk about Google Cloud for Web3, and more specifically, I'll start, talking about what Google is doing in the Web3 space. I'll also talk about the typical Web3 application requirements, and then we will talk about the key benefits of using Google Cloud Platform and a few reference architecture. I'll talk about a few things there, and then a quick slide on some customer references. And then we'll have as well a demo of a game deployed in GCP. Okay, so let's get started. Google in Web3. What we're doing. I think the Web3 vision for Google Cloud is really to make it easy for anyone to be able to build Web3 products, right? Providing efficient, reliable, and secure blockchain infrastructure. I think Google, has been a bit late to the Web3 space, and there is already a lot of very good tools and a lot of a big community already doing stuff. So the goal is really to combine effort and work with the community to drive adoption together. And we've done a lot of bounties, a lot of hackathon and events driving kind of like this driving forwards adoption and community together. So in terms of, if we look at Alphabet, right, as Google Alphabet, and we look at who is doing what and what is Google doing in Web3, I think the main actor is really Google Cloud, right? There is a dedicated digital assets team. There is dedicated Web3 teams. So, for example, the Web3 specialist team that I'm on. So you have a lot of dedicated teams that are working for blockchain customers and also building specific products for blockchain that I'm going to talk about. Then we also have Google Labs, that is formerly Google X, that is working on really more kind of like the core algorithmic, and a little bit like they look at it from a research and development perspective. So they have a team that is working on distributed computing and universal blockchain exploration, that is doing a lot of stuff in research, right, for blockchain. We also have a lot of Web3 partnerships. So we, for example, a member of the Hedera Governing Council. We're running validators in a lot of different networks, such as Polygon, even Solana, Ethereum, and so on. Google Pay has multiple partnerships with some exchanges and payment providers like Crypto.com, Gemini, Coinbase, and stuff like that. And then Google Venture and Capital G invest in blockchain, right? You can look at the investment that was done, but I think notable ones might be, for example, Fireblocks, right? And also Yuga Labs, right? The creator of Bored Ape Yacht Club. So I think that's quite interesting and give a little bit of some color as to what Google is doing. Okay, so if we talk, before a little bit explaining what Google Cloud is offering, I would like a little bit to explain what a blockchain-based application is and what are the requirements in terms of infrastructure. Oops. All right. So just a reminder that blockchain applications, or sometimes are called DApps as well, are just like any software, right? Like it's not radically different. You have a bunch of API, a bunch of microservices most of the time. And even though some of the logic of the DApp leverages smart contracts that are run on chain, so that would be the blockchain, smart contracts, tokens, shared data ledger, and so on. You still need an API management to read and write from and with the blockchain, right? So usually, because the blockchain are a bit slow to write, right? Depending on the blockchain and so on, I won't enter too much in detail, but depending on the blockchain, might be a bit slow to write, but especially to query data on the blockchain is pretty slow as well. So you don't really usually use the blockchain, but you would cache the information in some regular database instead of hitting the node directly, and especially because it can be a little bit more expensive as well. So the typical DApp also, involves stuff that's like listening to events from the blockchain, having some message queues, streaming data from the blockchain in some kind of orchestrator. So you would have just like a regular kind of application, multiple microservices, leveraging GKE, for example, is a good idea, and stuff like that. Most DApp, there are some caveats, but most of them, like 99%, will use private keys in order to sign transactions to send to the blockchain, right? Like admin keys for their smart contracts that are owner of some smart contracts and stuff like that. So you will need a secure process around key management. You will need to be in place, right? So that's the key. Maybe you can use like HSMs, maybe you can use software, key management and stuff like that. But you will need a dedicated process for that needs to be very secure. Okay, so if we look at the Web3 industry, and I think that they have really like different top of mind concerns and different KPIs depending on what they want to do and who they are. If we look at exchanges, so that would encompass like CEX, DEX, and NFT marketplaces that are slightly different as well. Basically, for them, and I'll just expand here. For them, the most important thing is really customer acquisition, because they are dependent on user transaction fees, right? So they will need to grow their customer user base pretty fast and retain them. And of course, you want to do that while having security and not having hacks, right? Like, of course, Mongox, very bad early in the days, was one of them. FTX recently, even you can argue it's not really a hack, but it was hacked afterwards. You have a lot of them that has security issues. So it's really like probably the most critical thing is around security and customer acquisition. So that's very important for them. When we look at infrastructure and tooling, such as Node as a service, taking as a service, these kind of companies, the first one would be reliability, and then of course security and scale. That I think for blockchain, because it manipulates money, tokens, assets, I think that's always going to be there. But so yeah, that's very important for them to be reliable and secure. We can also note around interoperability, because if you have a service, you might want to be interoperable with other services. You might not want, especially because blockchain is really portable, you might not want to lock people inside a specific ecosystem. You might want them to be very interoperable with different tools. That's really one of the motto of blockchain and crypto. And lastly, you have DApps, so decentralized applications built on blockchain, right? You have, for example, GameFi and DeFi. And so for them, I think the most important thing would be, of course, security and scale. We find it for or everything blockchain. But then I think the most important thing is time to market. How can they build what they want in a simple way as fast as possible? Is super important. Another thing as well is to get the user insights in order to build the best products, right? A little bit like product-led growth kind of mindset. And yeah, and so of course security here also a main topic here. So we see that there is really like 4 main solutions area that we need and that we are addressing at Google Cloud, right? First one being security, of course, and then developer experience, an API, data, and infrastructure. Right. So if we if we drill down a little bit to what are the key benefits of using Google Cloud Platform. All right. So let's look at the stack, right, from the bottom to the top, looking at really what GCP offers. The first one is infrastructure, right? Many customers choose GCP because we can provide massive, scalable, and secure infrastructure with low latency all over across the globe, right? There are many DApps now, and even like customers that are running in containers, right? And like GKE is probably the best place to run these nodes or these applications across the globe, right? But see, I think we're helping many customers to containerize the application with GKE to solve the problems. We reduce node time provisioning, for example, with automation. We maintain node application uptime, stuff like that. We have stuff like auto repair for GKE, for example, that are very important. And we have a lot of customers that are using it, like ChainStack, for example. They roll around 500 nodes across the globe on premises. And they also manage nodes on multiple clouds using GCP and TOS solution. So that's quite interesting in terms of infrastructure, especially for blockchain that wants to be decentralized. Many also gaming applications like Axie Infinities or the Running Chain, if you're familiar, are also running their games on GKE infrastructure. We can reach users all over the globe with very low latency. And that's why a lot of gaming customers also build on Google Cloud. If we go up the stack a little bit, we have the data layer. And so with BigQuery, I think it's probably one of the most well-known tool. We can provide real-time historical chain analysis data, visualization with Looker to track stuff like gas fees, transaction detail, indexing, like all of these kind of things that you want to take a look at. I'm going to talk a little bit more about it, but we do blockchain indexing. So we have a tool dedicated for Web3 that is basically indexing the blockchain data, and we provide for free like around 20 blockchain data sets, including BTC, Ethereum, Solana, Cardano, Polygon. We provide all of these data sets in BigQuery, and then you can just use them. And that's very helpful to help companies getting started, or even reducing the cost of operation. We also work with some exchanges to speed up the KYC process using stuff like Doc.ai. And also a lot of users use CDP, Vertex AI, BQML, and so on to understand the end customer and to have campaigns in order to retain them. All right, if we go up the stack a little bit, we have the API and developer experience. And here, API management, especially in blockchain, is very important. And we have APG that can really help expand the ecosystem, provide developer portals, and then having a really clear understanding of the API consumptions that you have and how to distribute it internally and externally. And that's very important because because blockchain is so interoperable, it's very important to have all these connections very easily for the developers, right? And then to accelerate the software development lifecycle, for Web3 front-end application, for example, we have like CI/CD, DevOps frameworks that can automate this process and increase developer productivity by a lot. And then lastly, security, right? So Web3, because it has assets, because it's money moving around, it's very important to be protected. Everything down to the core is basically cryptography with private key management. So it's very important to protect all of that. I think most of the hacks, the most prominent hacks that we've seen, like Ronin, Wormhole, like these kind of hacks, are really inherent to human vulnerabilities. And so that's why I think it's really the weakest link, right? Like user phishing and stuff like that. So, and most recently Ledger as well was hacked because of the phishing of one employee that had access to a GitHub. So these kind of stuff, very important. And so using stuff like zero trust solutions, Google Workspace is really important to reduce the risk of insider attacks, right? That's probably the most important thing. And then probably the second one afterwards, and sometimes go in pair, is private key leaking. So working with stuff like HSM, making sure that the private key never leaves the secure environment, and using stuff where it's very clear who has access. So Google Cloud has a very clear IAM, hierarchy of who can access, who can do what, make it very tight in terms of who can do what, especially with the private keys, is very, very important. And so that's why Google Cloud can really help on that front. And then for everything that is like DDoS, botnet, and so on, we have Cloud Armor and reCAPTCHA that is widely used. Most of the Web3 community already uses that, and it's great. So we should make it a norm to have these kind of things, right? And then to act faster in terms of cybersecurity, we have stuff like SCC, Chronicles. It really acts like as a cybersecurity operation center where you can capture like different incidents, have manage your logs and be able to have a better response time. And of course, across all of these areas, so security, developer experience, data, and infrastructure, we have partnerships. And so we have partners, ISV, that are also publishing their own solutions on the marketplace that are built on top of Google Cloud. And we have like chain analysis, we have node operators, we have private blockchain in a one-click deployment and stuff like that. So the ecosystem is much larger than just the Google Cloud tools and toolings as well. Okay, so I think a quick note on really like the network, because I'm not an expert, but we really continue to invest heavily in our network. And just this year, for example, we added 4 new cloud regions: Warsaw, Delhi, Melbourne, and Toronto. And so we announced also 5 new subsea cables which connect all parts of the world: Asia, Europe, Africa, and Middle East to Americas, right? So very, very important to realize that there is a big network, very robust infrastructure behind the scene that's working, powering all of that. Okay, so I think just a quick slide to really show and I think this timeline really well reflects the groundbreaking evolution of Google Cloud architecture, right? The transition from monolithic applications not so long ago in the end to containerized microservices powered by Kubernetes, right? I think that's the main idea of the slide, and it's a journey that began with early challenges to manage monolithic apps that led to the adoption of containers and then the end Kubernetes. And now it really encompasses like a fully containerized infrastructure. It delivers enhanced agility, scalability, resilience, most of all. And this transformation really highlights also the commitment of Google Cloud to innovation, but also open source, right? And basically the pursuit of cutting edge solutions in order to do more modern application development, right? So very important to realize, like, of course, Google is behind, Kubernetes and has been working a long time to provide a best-in-class containerization management. So currently, Kubernetes, really has become the most important and popular platform for customers to deploy game applications. Even I would argue also Web3 uses that a lot across all of the industry. And GKE is really the first managed Kubernetes cluster on the market and has the most outstanding features among public cloud providers. So there are mostly 5 benefits that administrators list out when they run containerized applications on GKE. And it's mostly regarding 2 different aspects. The first one is application requirements. And then the second one is requirements of the infrastructure itself, right? And the 5 benefits are listed here. Very quick, running up quick, basically initialization of the application very quickly, and then at the same time initialization of the infrastructure must also be very easy and quick, and that's very important. There are tools to support operations, and of course it supports high availability, resiliency. We see also availability features which happen to high availability for both infrastructure and the application, so that when there is errors in any component, then it will not affect the whole application, and that's really the goal of GKE behind the scene, and all of that without sacrificing any ounce of security, right? So that's really the most important thing, right? Like security, both of the infrastructure, but also of the containerized applications themselves, right? And those are really the 5 most benefits for using GKE for games, but also GameFi and Web3 in general. Okay. So all the apps will need to communicate with the blockchain, read and write from the blockchain. And while I think most will start with something like RPC as a service, depending on what you want to do, RPC as a service is very costly. And as the company scales, it's not even a question anymore. It will become more and more costly, and you will not have the choice then to either run your own or rely on dedicated nodes, for example, and stuff like that. And so in terms of hosting your own blockchain infrastructures, there are basically three options available right now on Google Cloud. The first one would be to use compute engine and basically run VMs with like high performance and highly reliable VMs. And we have the example of Dapper here. I think now mostly it moves to GKE, and we'll see that a bit later. But that's always the first option is always available. And for example, Dapper was really the first blockchain application to reach 1 million users with NBA Top Shot. And they did all of that using this compute engine to deploy the whole node infrastructure to decrease to increase the speed they would of like deploying the network, basically using the compute engine, making sure it's reliable, and making sure that especially it supports millions of users, right, at the same time, which is very, very important. And so that was massively successful on their side. The second option is to use something like GKE, right? And we talked about it. So I think that makes a lot of sense. Blockdaemon, for example, is one of our customer and partner, and they use GKE. And most of all, I think they use the auto repair feature from GKE to make sure that they monitor everything, and then they want to make sure that if there is an issue, then it also auto repair the node. It will be drained and recreated automatically. And if the drain doesn't really complete, then it shuts down and new node is created. Right? And this is how GKE can really help orchestrate and really like industrialize this whole thing behind the scene. And we see a lot of customers now using GKE for their node operations, but not only, right? Like their games and everything that they do. Okay, and the last option is blockchain node engine. So that's a dedicated product that we built for Web3 customers. And it's basically a fully managed, dedicated Ethereum, Polygon, and Solana RPC node as a service. And I explain the terms one by one. What it means basically is when we say fully managed is that it's basically you create a node and then we monitor, like Google, right? Monitors and ensure high availability, including the restarting and upgrading the node when it's needed. It's dedicated in the sense that when you compare it to something like Alchemy or Infura, it's an isolated node, right? What we do, blockchain node is isolated, so it's not shared with other customers. So you have the whole power of the node, which is, I think for Ethereum is about 1.5 billion requests, something like that per month, which is of course, for the price, I think it's 500 USD flat pricing. I'll show that right after, but it's unmatched, right? Because it scales the best option to scale is not RPC as a service. So you really have your own node and then you use it as much as you want to the limit of the hardware itself. So here it's a dedicated node. It's isolated from the other customers, and you can deploy it to the region of your choice. You can control access. It's also, because it's dedicated, you can put it in the same VPC as your application is based. And so you have the best-in-class latency. Right? If you use a service like Alchemy and Infura, for example, you might have something like at least 150 milliseconds for your queries. Maybe 100 if you're lucky, but about that. If you build on the same VPC, you should have sub 20 millisecond querying latency, which is obviously unmatched, right? To have in the same VPC. You could the only thing to match it would be to do your own node inside your own VPC, which obviously is kind of complicated. That's why we have these kind of tools. So we focus on the three major blockchain here, Ethereum, Polygon, and Solana right now. Ethereum is fully live. Polygon and Solana are in private preview. RPC, meaning that you access your node through RPC endpoints. That's the basis for Web3 customers. And then it's a node as a service. So you can easily deploy the nodes with API, CLI directly from the console. You can choose basically, but you can manage, much like you manage all of the other GCP services, you can plug APG on top of it, you can do AI, it's basically a part of the Google Cloud platform, which makes it very powerful. So yeah, in terms of pricing, was talking about it. Full node 500 per month, archive node 2000 for Ethereum. For Polygon and Solana, because they are in private preview right now, it's free. So if you're interested, you can send a request, and we can maybe give you access to the private preview. But we don't know exactly what the pricing is going to be yet, but it's going to be very fair, right? So the pricing is flat. It does not depend on what region you use and so on. It's the same for all regions, and yeah, that's pretty much it. So that's for like blockchain node access, right? And then I was talking a little bit about it before, data sets, right? So what Google is doing is that, I think I say 12 here, I think there are more now, but 12 of the top chains data sets are publicly available in BigQuery, and you can explore them. You can go on, on Google, on Google Cloud, and then look for them. And basically what it does is, again, when you want to read information from an RPC, it's expensive, and most importantly, it's not flexible. You cannot do the query that you want. You will get information from a very basic standpoint, and if you want to fetch a lot of data, do complex stuff, it's not going to be possible. So that's why most companies, they do indexing. So they just pass the blockchain every time there is a new block, and then they, pass this information on the database, and then they can query this database as they see fit. But that is very expensive, and that's what Google is doing for you. So basically what they do is that they run the indexes, they run nodes, and then they create an ETL pipeline to extract the information and make the raw data available in BigQuery. And that's exactly what the BigQuery public datasets for crypto is. And basically Google is paying for indexing, storing the data. You just pay for the regular BigQuery query. So you just query the data, and that's it. So there are a lot of users that use it, especially large customers can use it to create some kind of like dashboards or some analysis for history analysis for when you want to query petabytes of data, when you want to do stuff a bit more complicated, but also it's a very easy way to get started, basically, right? So we have a lot of tractions on this kind of stuff. Some of the data sets are community generated, and some are basically Google. You see here, maintainer. You have some of the data sets that are Google maintained with an SLA, and some of them are community based. But in both cases, depending on your use case, you can use it for your in production data. So this is an example of an ENS dashboard using Google Cloud and Looker, and also using the index data, right? So this is ENS, so Ethereum Name Service dashboard, which is very cool. So you can go online and look for it, and you can see all the data, and you can see that it has to fetch a lot of the information that are indexed and that's been indexed for a long time. So of course it's easier to do it from a data warehouse like BigQuery rather than do it from your node. I mean, it would be impossible to do it from your node directly. So that's exactly the kind of use cases that it unlocks. Okay, so I won't spend too much time, right, talking about the reference architecture here because it's just one example, but it really gives an idea of how we can, how we can use all of what we talked about and how you can put that all together in your application. But we can really get started easily with all the tools, the partner tools, the connections that we have from the Google Cloud Platform. So, if you have any questions, if you want to get started, don't hesitate to reach out. And very quickly also, because I think we can't really not talk about Gen AI, just a reminder that there is a lot of cool stuff that's happening. Google is really a pioneer in the space, and I recommend you take a look at the AI offering that Google has. Plenty of stuff available. Gemini was announced recently. It's pretty impressive, and so you can have access through Google Cloud, the APIs, and so on. And especially for gaming, there is a lot of stuff that are possible to do. Of course, you can help the game developers, doing the code, but more interestingly, I think doing the NPC dialogue, like really giving life to the games itself is really cool. You can generate the music, some stories, and like assets and stuff like that is really really interesting. All right, and last slide on some customer references, who is building on the Google Cloud Platform, and I think we touched a little bit upon that. Whether you are a protocol, an exchange or marketplace, a DApp, a digital asset services company, or infrastructure and dev tooling, there is a lot that we can bring on the table, whether it's on security, cost saving, time to market, reliability, efficiency, everything that we basically talked about. A lot of these companies that are here as well, we are close partners, like Polygon, for example, where we have some tools to make it easy to create a Polygon node and access the data through the data sets and stuff like that. So yeah, I think that's it. Thank you very much for your time. Don't hesitate to reach out if you have any questions. And yeah, you will see the demo for the game deployment. Thank you very much.
Hello everyone, my name is Đức, Cloud Architect, part of the Web3 and Gaming team for ASEAN region. It is my pleasure to meet you in this hackathon. In this demo, I want to show you how you can develop and deploy a Super Mario game in GCP by leveraging state-of-the-art technology like GenAI, code assistant, containers, and Kubernetes. I will show you the concept how you can generate game asset using GenAI, code the game with code assistant using Duet AI, and then containerize the game and deploy the game using GKE with Kubernetes in just minutes without worrying about scaling. In order to develop a Super Mario game, you will need game artists to draw and generate the game characters like Mario, Luigi, Princess, or the Dragon. It may take a lot of time to do, but with GCP and generative AI technology, especially using Vertex AI Imagen, you can use prompting to generate image and game asset. This is the user interface for Vertex AI Imagen. For example, in this demo, I will using this prompt to generate some of Mario character. I can use this to build my game. When I click generate, here are some results that I got. I can choose and put them into my game engine to develop my game. You can see that this is the prompt that I use to generate the Mario. When I click generate, the Vertex AI tool will help me to generate some of the results with many options for Mario character. Let's say now I want to generate the princess character. I just need to use another prompt. Let's say I want to use a princess character in this Super Mario game and click generate with the same process. The tool will run and generate some result for me. So this is some of the princess character that I can filter, and then I can fine tune and use it later. You continue to use this tool to assist artists to generate all game assets with the same method. Now, next task, after I got all the character and the background in the game using generative AI, I will need to code the game logic. It is a very heavy lifting task for the game developers. Now let me show you how you can leverage generative AI with Google Cloud, Duet AI for developers to assist game coding. Let me switch to IDE Visual Studio Code to show you how it works. Give me some minutes to switch to the new Windows. So this is a very familiar Windows from Visual Studio Code. And my IDE already got integrated with Google Cloud Duet AI for developers. This tool can help me to generate code, recommend code, debug my code, explain my code, document my code, build a unit test for my code. You can see I can type into the chat windows over here to write Super Mario. For example, I write the chat into the chatbot to write Super Mario code using Python. Duet AI will recommend me. I just need to copy and paste, or just click the side button to add into my code windows. Now let me key in the prompt. Write Super Mario, and right after you can see the recommendation. I just copy and paste, or just click the side button plus side button here, and then I can start testing my code. And if something wrong, I can ask Duet AI to debug for me. After I finish writing the code, I can easily use my knowledge or using the code assistant to debug my code. So with the generative AI technology, it helped me a lot, not only for game artists, but also can help the game developer to write the code for my games. So with this tool in place, it can help me a lot to accelerate the go-to-market for the games. So after I finish writing the code, now I will start to deploy it using Google Cloud environment. Give me some minutes to bring it up. So here is the Google Cloud Console Windows. After writing my Super Mario game, package it, I will start to containerize it and deploy it using GKE Kubernetes from Google Cloud. I will start to bring up my Cloud Console and Cloud Editor. This is a very convenient tool for developers in Google Cloud. It is like a cloud machine for developers in Google Cloud. And it has 5 GB persistent disk to save all my code. It integrates with GitHub, and you can control any Google Cloud service using Google Cloud G-Cloud commands. To containerize my game, I will use Docker, a very popular tool to containerize the apps. To do this, the Excel file that I package my code, I will put them into this folder. And I already prepared a Docker file to list out all library dependencies and operating system to run my Super Mario games. In this case, it is a CentOS. I install some dependency for my game to run. Copy the code into the container and expose port 80 for my gamers to access using web. Now I will run the code. After finish preparing the Docker file, I will run the code to build container, and I will need to upload it into container repo called Google Cloud Artifact Registry. So let me show you how to do it. So I will need to authenticate with Artifact Registry and doing some setup for my Google Cloud Shell. So let me show you the repo, the Artifact Registry repo, before I build my game. You can see that it is still very empty. There is no container image inside this repo. Later, when I finish building the Docker image, you can see that there are there is Super Mario container image in this artifact registry. Let me start the process. To containerize it, I will need to authenticate with my artifact registry and run the Docker build to ask Docker to find my Docker file and run all steps in this Docker file, like install CentOS, install dependency library for my games, copy the source code into the container and expose port 80 for the gamer to access into this game. And you can see that when I run Docker build, the process will stop and list down all the steps for me. It will do all the steps automatically for me. And it will take a while for the Docker to finish all the steps in the Docker file, because it needs to download the CentOS, install the OS, and then install all the library, update the package inside the CentOS, and then copy the code from my local folder, the Excel file that I already packaged my Super Mario game, and then it will run the commands. While waiting for the process to finish, let me show you the Kubernetes YAML file to deploy the Super Mario game. In this YAML file, I deploy the container and expose port 80 for my gamers to access it. So this is the manifest registry that manifest YAML file that I need to prepare to deploy it inside the Kubernetes cluster. And inside this deployment file, you can see the image, and we need to point the location of the container image in the artifact registry that I will upload my container image to. It will take some time for the Docker to finish all the steps in the Docker file. We can wait for some time. Although you can automate all the process and this step using CI/CD, but in this demo, I want to show you step by step. You can compare it with traditional process without container. If they finish the code, they will need to hand over the code and all the dependency needed to run the code to the operation team. The operation team will need to prepare the machine, install the operating system, library, and import the code into the machine. Handle all the operation patching while the container, while with the Kubernetes and container. It will help you to simplify this process. The developer team, after coding, DevOps team will prepare this Docker file to containerize the code and upload the container image to container repo. This container image already contains all the library and dependency and the source code inside the container image to run the game. This game can run anywhere because the operation team just need to prepare a machine with the container engine and pull down the image from the repo to run it. This machine can be anywhere, and it is the same process. Besides that, when you deploy your games in Kubernetes, you get many other benefits compared to traditional monolithic architecture like auto-scaling, high availability, and Kubernetes is the open source, so you are not locked into any provider. And all the cloud vendors in the market now, they support the Kubernetes. Now you can see the build already finished. I can use Docker image to check if the image is there in the local machine. And you can see there is a Super Mario container image here. Now I just need to run a command to push this image into container repo, which is Google Artifact Registry. It takes some time to upload the image from my Cloud Shell machine to Artifact Registry. Now, depends on the internet connection between my laptop to the Google Cloud. It may take some time. Now the upload process will need some time. So while waiting, I will get back to the GKE, which is a Kubernetes, Google Kubernetes engine, where we will deploy our Super Mario game. I already create the GKE cluster. Let me go into this GKE gaming cluster to connect to this cluster. I just need to run this command. Run this command in the Cloud Shell to deploy the game. To create a GKE cluster in Google, it is very simple. Just go to GKE and you click Create. The autopilot cluster is the simplest way to run your apps. It is a serverless Kubernetes to offload all your Kubernetes operation tasks. Now you can see that you just need to name the cluster, specify the location of the cluster, and all the setting you just put it as default. Because with Kubernetes GKE autopilot, it is very simple for operation team to create and operate the Kubernetes cluster. Now the upload process is done. Let me open the container repo to show you the image already been uploaded. When I click refresh, you can see a Super Mario image uploaded 1 minute ago. Now let me deploy. To deploy, I already prepared a YAML file with container image pointing to my artifact registry location, which I just uploaded the image. Now let me run a command to apply this YAML file into gaming GKE cluster that I created before. Because I already connect to GKE autopilot, and when I run the Kubernetes apply, it will automatically deploy the Super Mario game into my cluster. And let me note a little bit on the GKE autopilot. With autopilot, because you don't need to care about the nodes at all. When I start to deploy the Super Mario game, GKE will automatically check the Super Mario gaming resource requirement for me, and then it will automatically scale up the node for me. With autopilot, you don't pay for the node, you only pay for the application resource running in the cluster. This is the one of the best benefits of GKE autopilot. Let me show you how long does it take to spin up and scale up a node in GKE autopilot. It takes only some seconds, 29 seconds to be exact, to provision a node. You can see here, there is a node already in node ready. That means it already provisioned the node to support my Super Mario game. And you can see from not ready until ready, how long does it take for the node to be provisioned. You can see it only takes 29 seconds. And when the node is ready, the pod will turn into running mode from pending to running mode very easy. And you can see it is in container creating now. Compared to scale up a cluster in on-prem or in a private data center, it will take a lot of time. You will need to check the resource needed, buy the RAM, CPU, server, install the operating system, install Kubernetes, and join the new node to the cluster. With GKE autopilot, it only takes 30 seconds to spin up a node. So when the Kubernetes pods, my Super Mario pods, turning from container creating to running, that means my game's already deployed inside the GKE autopilot cluster. I can easily connect through the games and play the games. It takes some time because it needs to download the container image and then deploy it into my GKE autopilot cluster. Now the pod already up and running. I can find out what is the public IP address to connect to the game. So I just using a get service, and I can see this is the public IP address that the gamer can use to access into my game. And in the real world, you can easily use ENS. Public DNS to put in front of this public IP, or you can use many game server to upload and to load balance between all the game server. So after I see the public IP, I can access it using the Chrome or any website, and boom, here is the Super Mario game. That I can easily play from all over the world because it has a public IP. So that is the conclusion for my demo. You can see that in this demo, I already show you from start to how to using Google Cloud technology to assist create a game asset, to assist coding the game. And then I easily deploy, containerize the game, and then deploy it into GKE autopilot cluster. Thanks a lot for listening.